just reviewing over again one more time. Starting with the problem, we said that Orchard A, remember we said it has $9 per person, 3 chaperones have to go. Remember the cost is per person, so it's not just per student, it's per student and chaperones combined together. Orchard B, $10 per person, only 1 chaperone that's required to go. And again, you're paying the same price whether you're an adult or you're a kid. Leah, move down. All right, when we're looking here at partner A, Orchard A, so the partner A people, you were only focusing on Orchard A. You were focusing on how much it would cost for 8 students, 12 students, and 30 students. And if you were reading through, you would have realized that the expression that belongs with it is that you're taking $9 and you're multiplying it to the quantity of taking however many students there are, plus the 3 adults that have to attend no matter how many students there are. That's where they're getting this expression that they wrote down at the bottom. Reese? It is, I know. That's why I called on you. All right, n plus 3. So the number of students, whether it's 8 students, 12 students, or 30 students, we're going to add 3 to it, and then we can multiply that value by 9. So when you're working through it, you should have noticed that you're having 8 plus 3, which is our 11, and then multiplying that by 9, and you'd get a cost of $99. And please tell me that you guys understand that you're supposed to put your dollar sign ahead. I had like 7 students in the last class who put the dollar sign afterward. They said, but it's $99. No, dollar sign goes in the front. Always. Huh? Yeah, it's $99. The dollar sign goes in the front. All right. So for here, for problem number 12, again, we're taking 12 students. We're going to add the 3 chaperones, Iris. And then we're going to multiply that value by 9. So it's going to come out to $135. And then if we've got 30 students, again, we're taking 30 students, adding the 3 chaperones. That's 33 total people that are attending, multiplying that by 9. And you should have gotten $297. So this is the breakdown of the cost as we're progressing through different numbers of students. Again, make sure you're paying attention and not watching somebody put on their class. Saying. All right, for problem B, Orchard B, okay, they had the expression, again, same kind of idea, 10 times the quantity of n plus 1. This time only 1 chaperone is required to go no matter how many students are going to attend. Okay, so again, we're focusing on 8, 12, and 30 students attending. So that means we've got 10 times the quantity of 8 plus 1. So that means 9 total people attending. That's going to come out to $90. So it happens to be that Orchard B at 8 students is the cheaper price. And they're cheaper by how much? $9. Okay, so Orchard B for 8 students is going to be the cheaper cost by $9. Okay, for 12 students, again, we're taking the 10 and we're going to multiply it by the quantity of 12 plus 1. That means we're doing 13 times 10. That comes out to $130. So again, oops, 130. Again, Orchard B is still cheaper, but now they're only cheaper by how much? $5. So the amount that they're cheaper by is starting to get smaller as we progress to having more students. So we get up to 30 students. Once we get to that 30 student mark here, so we're taking 30 students, we're adding our 1 chaperone for a total of 33 or 31 people, multiplying that by the $10, and we get $310. Now Orchard A is the cheaper price. Okay? So at some point, what we're showcasing here is at some point, Orchard A changes to be the cheaper orchard. That's an inequality. We're trying to figure out at what value of students is it cheaper to go to Orchard A than it would be for Orchard B. These are things that we do constantly when we're trying to figure out things like field trips to go for you guys. Or if you're trying to figure out, hey, I need to buy certain school supplies. Looking at when is it feasibly cheaper to go here versus there. Okay, Costco, grocery shopping in general. Okay, at what point is bulk buying not actually going to be cheaper for you in the long run? Okay, you're trying to figure those things out. This is consumer concepts. Inequalities is big with consumer concepts. So you want to make sure you have a good understanding of that. Taking a look here, looking at what our inequality is. So they saying, hey, basically this being Orchard A, So I'm going to write down that this is Orchard A. We want to know at what point is A less than B. So 9 times the quantity of n plus 3 is representing Orchard A. Oop, I misspelled orchard. And then 10 times the quantity of n plus 1, that's Orchard B. And then we're actually solving the inequality itself. So setting up what they've got, we have n plus 1 inside, or sorry, n plus 3 inside of parentheses, multiplied by the 9. And we want it to be less than 10 times the quantity of n plus 1. So the first thing that we have to do is distribute, right? 9 times n and 9 times 3, that becomes 9n plus 27. 9n plus 27. Then we're doing the same thing here. We're doing 10 times n and 10 times 1. That becomes 10n plus 10. So we've got an inequality with variables on both sides. Some of you really struggled a lot when it came to solving inequality or equations with variables on both sides. Okay, you really need to make sure that you're paying close attention to the steps. Distribute, combine like terms if you can. You're going to transfer or maneuver so that your variable is on one side of your inequality or equation, and then solve. So right now we have a variable on both sides. I want my variable over on the left side. Needs to be on the left side. So that means I'm going to have to subtract 10n. Now some of you on your test, you're like, oh yeah, I'm going to subtract 10n from here, and then I'm going to subtract it from 27. Why are we not doing 27 minus 10n? Asa? Because it's not a like term, right? You have to have like terms for your subtraction. That's why you have to do subtraction, in this case, with your variables. That 10n is going to get canceled out. 9n minus 10n is going to become a negative 1n plus 27. That's less than a positive 10. From here, we can then go ahead and start solving by subtracting 27 from both sides. That gives us negative 1n is now less than negative 17. And then we would divide both sides by negative 1. And I'm sorry, I'm running out of space there. Now again, the note that I need to make, anytime I multiply or divide, I want to make a note. I am currently dividing, right? We are currently dividing by a negative value. We're dividing by a negative value. So what does that tell me to do? If I divide by a negative, it tells me to what? Flip the sign. Flip the inequality sign. You're going to flip your inequality sign. So this symbol that I'm highlighting right now in my orange, that sign, that symbol is going to flip and reverse. Put it away. Okay, so that's going to give us n is now greater than a positive 17. So we need to know, what does that mean in context? What does that mean? When I say n is greater than 17, what does that represent? Ari. Okay, it could be 18. But we're talking about in context to the problem. When I tell you, oh, n is going to have to be greater than 17, what did n stand for? Number of students. N represents the number of students. So what does it mean by the students need to be more than 17? What happens when students are more than 17? Read the problem. What were we trying to figure out? Anissa? Which one did we say was going to be cheaper then? Asa? Yeah. At this point, this is the point of when Orchard A becomes cheaper. That's what you're trying to say. When they're talking about the context of the problem, when you have more than 17 students attending that field trip, it's cheaper to go to Orchard A. At 17 students, If there are exactly 17 students, then both orchards would actually be the same cost. Anything lower than 17, orchard B is the better deal. Okay, that's what these inequalities are representing. So when they're saying explain the solution in its context, that is what they mean. Okay, orchard A is the better deal if more than 17 students attend. That's what you're trying to figure out. Guys, a lot of the questions that you will be doing, it's taking context and identifying the solution, not necessarily like this, but like this. That at this certain point, this is when it's a better deal. Some of you aren't facing the board. Thank you. Okay, now we're graphing the solution. Okay, I had some students say, I don't understand, what do they mean? There's no numbers down here. If there's no numbers, what do you think you need to do? Write down some numbers. Okay, don't be lazy. Okay, write down some numbers. I'm just going to put 17 anywhere. The fact that I put 17 here, that means that the numbers behind it, this is 16, this would be 15, 14, 13, 12, 11, and 10. Okay, it doesn't matter where you start. Hey, if you started at 1 and went up, I don't care. As long as you at some point have 17 graphed here and then have some of the other numbers written in. I'm not going to write everything because it's going to take up too much time. But when showcasing my graph, the important thing is to make sure that wherever 17 is located on my graph, that I have an open circle and that I am graphing to the right. I have an open circle and I am graphing it to the right. That's the important thing. All right, are there any questions about this? No. Okay, flip it on over to the back. Okay, same kind of concept here. Part-time job. He's wanting to work 2 different types of jobs, or he's getting offered 2 different types of jobs, and he has to identify at what point does it make more sense for him to work at the hotel versus working at the restaurant. Okay, for the hotel, it pays him $18 an hour, and then he also gets an additional $35 for just transportation allowance. That's not per hour. That's just for the month. You get paid every single month. You know, some jobs get paid once a month, some jobs every week, some jobs every 2 weeks. But in this situation, he's getting paid once a month. He gets a $33 charge given to him, or a payment given to him, and then $18 for every hour that he's actually going to work. At the restaurant, he's going to get $7.50 an hour for himself. Then he also gets to split the tips. He gets about $50 in tips each hour that's going to be split equally amongst 4 wait staff. So that might sound confusing, but the nice thing is that they already wrote it down here. Essentially, if you were to simplify this, though, we could simplify this, right? 50 over 4 simplifies to $12.50 per hour. And then you could even combine that with the $7.50 per hour to equal $20 per hour that they would be making. Okay? Yes?
But if, like, everyone else is also getting tips, wouldn't they also share with you?
That's what we just said. It's $50 for the hour, yes, split amongst 4 people. Split amongst the 4 people.
Yes, but if the other 3 people is working and they divide...
They're saying that the entire wait staff typically collects a total of $50 each hour, right? Do you understand now? Yeah. Okay. So it helps to make sure read and reread if you need to. All right, so these are basically your 2 separate scenarios that are being set up for here. So for very first scenario, we've got 18 times the H plus 33. Okay, so for 1 hour, it's going to be 18 times 1 plus 33. That's going to come out to how much money? $51, right? Okay. Then we're going to have, hey, at 10 hours, we're going to do 18 times 10, and then we're going to add 33. That's going to come out to $213. Then we have 20 hours. That means we're doing 18 times 20, and then we're going to add the 33, and that comes out to $393. Okay, for restaurant B, or partner B, restaurant job, again, they're putting it out here as $7.50 per hour plus the $50 out of 4 people per hour. We know that that's really $20 per hour if you simplified that expression, but they want to do it the long way. So $20 times 1 means that if you work 1 hour at the restaurant, you're just going to make $20. Significant difference between restaurant work and the hotel work, isn't it? But then no one's going to be working for just 1 hour. Let's say you work for 10 hours. And that's not just in a day. Obviously, they're not working 10 hours for the day. But 10 hours out of the month, if you work 10 hours for the month, that's going to come out to $200. Not that far off. Working 10 hours a month versus at a restaurant versus 10 hours a month at the hotel, it's only a $13 difference. Then when you get to the 20 hours, now the restaurant's making $400. Okay? So that means at some point, the restaurant job becomes the more lucrative deal. It means that you would make more money in that situation. Okay? So here, like we said before, the hotel is cheaper, makes more money for the first hour. It makes more money for 10 hours, but then it's the restaurant that's making more money by 20 hours. Yes?
It's 200.
Oh, sorry, my bad. I don't know why I even have it as a 200 right here. Okay, thank you. Now, taking a look here, here's our inequality. Again, this first part of the expression is going to represent our hotel. The second part of our expression is going to represent the restaurant, okay, or job B. So then we're going to solve our inequality and identify the interpretation. So 18H plus 33, we want to know at what point is the hotel going to be greater than or equal to the restaurant, which, like I said, that's 7.5H plus the 50 over 4 times H, that just comes out to 20H. So we would subtract 20H from both sides. And again, guys, just because we're subtracting here doesn't mean that we no longer can work the problem out. If we're doing 20H minus 20H, that just becomes a 0. 0 is still a number. Do not think that everything stops just because you got a 0 in the problem. It's fine. Okay, when we subtract, we get negative 2H plus 33. We would then subtract 33 from both sides. You're going to get negative 2H is greater than or equal to a negative 33. And then you would divide both sides by negative 2. Now we're dividing by a negative. That means that that inequality is going to flip to less than or equal to. You get H is less than or equal to 16.5. So what this means is that at 16 and a half hours or less, it's better to work at the hotel. Okay? The hotel, your hotel earns more money at 16 and a half hours or less. You earn more money working at the hotel if you plan to work 16 and a half hours or less. Anything over 16 and a half hours, you're going to want to go ahead and work at the restaurant. All right, we only have a little bit more time. We're going to go ahead and move on to page 3. Page 3 is just taking some of the scenarios. They gave you the equation setup or the inequality setup. Now you are setting up the inequality and solving and writing the context of it. So taking a look here, we have TJ has a salary of $42,000 and a raise of $6,000 per year for one job offer. Another company is going to give him $62,000 for his salary, and he gets a raise of $2,000 per year. So we want to know after how many years is TJ going to make more money if he accepts the first offer. If he accepts the first offer. Okay, so we want to know at what point is the first offer greater than the second offer. Okay, making more money means it would have to be greater. So taking a look here, if we were to set up the first offer is just giving us $42,000, plus they're going to give us a raise. Every single year you get another $6,000. Now we want to know, at what point is this going to be more? Is he going to make more money? Remember, more means greater than. So we're going to put a greater than symbol, and then we're going to compare it to the second offer. The second offer is going to be $62,000 starting. And then you get another $2,000 every single year. Again, real life situations. Sometimes when you are searching for a job, when you guys become an adult and you're getting out there into business, you're going to be applying for more than just one job. Okay, smart people sit there and put their resume out. They apply, like my husband, when he's applying for his first job here in Atlanta, he applied to 7 different places. Okay, he got offers from 4 of them. Then he had to go through and start thinking, well, which one's going to wind up being the best deal for him in the long run? Yeah, this job, I'm going to be starting off really, really well. But he also learned that they don't really move up much. So he would kind of stay stagnant after a while, meaning he wouldn't get as much money if he starts off a little lower. But each year, he gets a nice good bonus, and he would move up in the company, which means he could get more raises. So you have to look at those kinds of things and think, is it worth it for me to take the big money now and maybe only stay for a little bit and then have to move to a new job after 2 years? Or do I want to stay for a long time? So maybe I want to work at a smaller end job where I'm going to have more room to move. These are things that are real world situations. Okay? All right. Taking a look here, the first thing that we would do is we'd go ahead and subtract our y's. So we're going to subtract 2,000y from both sides. That's going to give us 42,000 plus 4,000y is greater than 62,000. Then we would subtract 42,000. That's going to give you 4,000y is greater than 20,000. So then you would divide both sides by 4,000. And you're going to get that y is going to be greater than 5. Okay, I'm not going to worry about the graph anymore because I think you guys are fine with the graph, but I do want to, again, focus on what the solution means. What did y stand for? The years. Now it says years is greater than 5. What does that mean? That if you stay for more than 5 years, what job is better? The first job. Okay? The first job, or the first offer, is better if you stay for more than 5 years. If you are planning to stay longer than 5 years at your company, then it's better to go with the first job than it is to go with the second job. Again, not starting off with a lot of money, but they're making a lot more with their raise. All right, taking a look, same thing, texting plans. When you go for a cell phone, you have to figure out which plan is the best plan. Okay, sometimes they might offer a free phone, but they might have more of a charge per month for the data that they're going to let you use. So, okay, back in the old days, when we were getting phones, you know, as old people, you had to pay for text messages. Yeah. You had to pay for every single text message sent to you. So I remember, like, if anybody decided that they were going to text me, it had better be worth it. Do not do one of those rapid text messages because it costs money every single text message. So what you had to say, if you couldn't say it in one single message, then you better pick up the phone and call. Okay? And even then, back then, we also had to pay for minutes to talk on the phone. Yeah. You didn't have these, like, internet plans or anything like that. So phones have come a long, long way because it really wasn't that long ago. That was less than 20 years ago that they were still doing that. Okay? Jack?
So couldn't you then if you had to send out like a whole whatever, you could just send it in one text and you pay 2 cents.
It cut off. You had a characters limit.
Oh my.
You had a characters limit. And so if you went over a certain number of characters, it would send it as multiple messages. So I remember my plan when I was growing up, it cost 25 cents per text. Doesn't seem that much, right? Except that if you go through, I mean, think about how many text messages you send a day. Okay, we'll go over this tomorrow.